Hey everybody, this is Mr. Munson. We are going to be taking a quick look at polygons. I'm going to call this unit G.7, polygons of course, and there's only one concept that we're going to be dealing with in here, so it's going to be a very fast unit as you can see, and we're going to do G.7.1 polygons, and we're just going to quickly explore what's the reality about the interior angles and the exterior angles. Let's get started. So there's going to be a few vocabulary words that we're going to be dealing with in this unit, okay? You hopefully know what a polygon is. That's just basically a shape with sides, right? But we're going to need to know what convex is if you don't know what that is. Hopefully you know what interior angles are, a single interior angle formula. We'll have to explore that. An exterior angle formula, single exterior angle theorem. What is a regular polygon? Interior angle sum theorem. Exterior angles, hopefully you know what that is, and then what concave is. So by the end of this video, hopefully you'll have at least those things in your notes so you can kind of go back and reflect on them, and then we'll be ready to get going. Okay, so as we walk into this, we're going to be dealing with more than just triangles and quadrilaterals, four-sided figures in this year, and so we're going to need to make sure that you have the proper names for these shapes. So I'm just going to quickly list them here so that you have them reference. I'm going to suggest not only do you put them in your notes, in your video notes, but maybe at the front of your video notebook, maybe the very first page it's blank, or maybe inside the cover, so that you can kind of refer back to it without having to find it here. Or maybe it never goes in your video notes. That's just simply where you put it, right there in the front cover, someplace to be found quickly. So let's go ahead and run through these. Obviously, if it has three sides, it's called a triangle. Four sides, it's called a quadrilateral. Quad meaning four. Okay. And then five sides is a pentagon. Now I'm going to go ahead and finish writing these up, and then I'm going to put on pause, write them all in there so that we don't have to spend time you watching me write them. All right, and there you have them. Most of them you've heard before. Us living in the DC area, this one's kind of easy. We got the pentagon, which is a five-sided figure. Heptagon and hexagon, those are the two. I flip those by accident all the time in my brain. So you come up with whatever method you need to do to remember which one is which. Octagon is like an octopus. Nonagon sounds like nine, a couple letters difference. Decade, a decagon for 10 years, 10 sides. What would you call an 11-sided figure? An 11gon, right? And then a 12-sided figure is a dodecagon. That's my favorite one. Of all the polygons, that's my favorite. And from that point on, we'll just simply write the number, put a dash, and write the word gon. So a 27-sided figure would have 27 sides. We'd call it 27gon. All right, so let's start our notes if you haven't done already. And I'm sorry, let me fix this. I should say 7.1 polygons, and hopefully this goes pretty quickly and pretty smoothly. We have a convex polygon and a concave polygon, so this shape basically collapses in on itself. I think of it as a cave. Convex is there. There's very technical names for it, like if I grab 2 points of a shape and I draw a line, and every time I do that, those lines exist inside the polygon. That is an indication it's convex. And you know, let's see, if I grab this one, I'm sorry, not that one. Let's say I grabbed this point here and this point here, and I drew a connection to there. That appears on the outside. I think it's just easy enough to see that a concave kind of pushes in on itself. All right, now let's talk about regular polygons, okay? Now, we have in this first shape here, we have an equilateral polygon. You can tell by all the sides are congruent. The next one, we have an equiangular polygon. All the angles are the same. Then we add those two together and we call that thing a regular polygon. So if I tell you something is a regular polygon, you automatically know that all the sides are congruent and all the angles are congruent. Hey, take a real quick quiz and see if you can write down the names of those without looking. Put me on pause and see if you can do that. Do as many as you can. If you have to skip them, you have to skip them for now, but that's something that you'll want to make sure that you have. All right, put me on pause. There you have it. Of course, there's my favorite, dodecagon. I just think it sounds like a dinosaur instead of the sides of a triangle, right? I was running outside. I was playing some soccer, and we got attacked by a herd of dodecagons, and they came after us. All right, let's keep on. Now, you already know the sum of the interior angles of a triangle is 180. Okay, and you probably know for a four-sided figure it's 360, and I've kind of explained this to you a couple of times in the sense of it's really two triangles put together, right? So the sum of a quadrilateral. All right, so there's that, right? So if I was to have, in this quadrilateral, certainly I have four angles, and what I know that is, if I added up those four angles, whatever they are, numbers or expressions, they're going to equal 360 degrees. Okay. Now the question I have now is, what about a 12gon or a dodecagon, as I like to call it? Um, how would we calculate that one? Let's take a look. Now I don't want to get used to drawing my shapes and then cutting it up into triangles and all those things, but let's see if we can start and come up with a pattern, something that's going on that will help us just calculate this right off the bat. Okay. So with a three-sided triangle, there's one triangle, right? Okay. Then for a four-sided figure, like a shape like that, there's two triangles. See if you're catching on what the pattern is. For a pentagon, there's three triangles. Okay? Now, look at the relationship here between the number of sides and the number of triangles. You see the pattern? I want you to use some inductive reasoning to figure out, if I told you the number, like let's say 12, could you predict how many triangles are in that figure? See if you can do that now. Put me on pause and come back and check your work. Yeah, I'm hoping that you said it was 10. We basically take the number of sides and then we subtract 2 from it to find out how many triangles in it. And so once I know how many triangles in it, then it's just a matter of taking 10 and multiplying times the sum of all the angles that would be in each one of those triangles. So this is my calculation for this one. The sum of a 12-sided figure is 10 times 180. That 10, again, is 2 less than the number of sides. I want to come up with a formula for that. There we have it. We have the sum of the interior angles theorem. Basically, it says the sum of the interior angles. So I have this like little notation down here. It's a little subscript to help me know that I'm talking about the sum of the interior angles is equal to 180. That's the amount of angles that are the degrees that are in each triangle, times the number of triangles, which is the number of sides minus 2. We just discovered that. So let's just see if you can do this. Here's a 27gon. I'm not going to draw it, but I am going to ask you, what's the sum of the interior angles equal to? Go ahead and do the calculations, not on your calculator, write it out. So it's going to go 180, and then keep on going. Write that out, then go to your calculator and calculate it up. Put me on pause, come back and check your work. Okay, so I got the sum of a 27gon to equal 4,500 degrees. That means if I drew a 27gon, right, 27 sides, I can't do it. It's just too much. And I was to add up every angle that was inside this thing, right? They would equal, the total would be 4,507, or 4,500 degrees. All right, let's move. So take another chance at this. Go ahead and see if you can write the names of those shapes one more time on your own, just quickly, as fast as you can. At least maybe you got another one stuck in your head now, and you can do this. Go ahead and put me on pause and give it a shot. And of course, the last one, dodecagon. If you get that one wrong on the test, it's just going to make me cry. All right, let's see how we're going to use this. So if you take a look, I have this angle over here at y that's unknown. and I want to know what that angle is. So I'm going to have to write an equation. I don't care what variable you want to put on it. We'll put the letter y on it, right? But now we have to write an equation. All right. Now I do know that if I add up all those angles, it should equal some number. So that sum can be calculated. So let's start there first. Now you're going to be doing this on your own, so just kind of watch me and write it in your notes. So let's look at the sum of the interior angles, right? That's going to be 180 times n minus 2. That's where we're going to start. Let's calculate that number first. So the sum, and this is how many sides? Let's count it. You got 1, 2, 3, 4, 5. So the sum of a five-sided figure is 180, 5 minus 2, which is 3 times 180, which is 540 degrees. Now we're going to do this often. I'm going to do this often enough. I hope that you follow me. You're going to do this often enough that not only do you now remember the sum of the interior angles of a triangle is 180, but you'll know it for a pentagon, hexagon, because we're going to do a bunch of these, and you'll just know them off the top of your head. If not, then you come back to this equation, and you write it, and then plug in the numbers, and you get it. Okay, so now what I'm going to do is I'm going to write an equation to solve for that unknown. So let's add up all the numbers. The sum, 110 plus y plus 150, and I'm just rotating around it and adding the pieces up. That sum should equal 540 degrees, okay? Just like the triangle, right? I always added up all the angles on the left and made it equal to 180. In this case, 540. Now I'm not going to take your time to solve that equation, because I'm sure that you can find y. But once you do, you will have that angle amount. Now I want you to go ahead and set up this one. You try it. Go ahead and set up this one. Let's see, 1, 2, 3, 4, 5. It's 5 sides again, so you already know what it's supposed to be equal to. Still 540. Just write the equation. Don't worry about solving it. Come back and check your work. There's what I have. Now I just, on my own, started here at 117. You could start wherever you want. Something I forgot to say is, a lot of times students, when they go to write an equation for this, they'll forget to put into their equation that 90. Okay? So it might be helpful for you, just in the time being, when you see that 90 is automatically put a 90 there, so you know that it has to be included. But altogether, you need to have 5 separate angles on a 5-sided figure. Okay, here you go. Now, there's no picture. I'm just asking you to find the sum of the interior angles of a hexagon. Now it's in words. So go back to your vocabulary words and find out how many sides this is and find out what the sum is. Off you go. Put me on pause and come back and check your work. All right, there you have it. All right, I know that one didn't say you try it, but I went ahead and had you try it, right? Let's see if you can do this one, an octagon. And there's that one. Now I'm using this little subscript down here to kind of keep track of what I'm finding. This is the sum of an 8-sided figure. I encourage you to do that same. All right, now let's take a look at the exterior angles. So a triangle has more than just one exterior angle. A lot of times in the problems that we're looking at, we'll have a problem like this and there's just one exterior angle we're looking at. But there's really 3. Each vertex has its own exterior angle, right? Exterior angle is created by extending a side. Here's a side extended, and then the other side. Okay, so here's an exterior angle, and here's an exterior angle. Now, I'm going to ask you to find the exterior angle value on those 3 angles. Now, remember, you're just using the linear pair postulate to do that. So go ahead and draw that picture into your notes and find those exterior angles for me. Just make sure that you can do that part before we move on. Put me on pause, do that work. All right, if I did my calculations right, you should have 130, 80, and 150. All right, now let me show you something kind of cool. The sum of the exterior angles of a 3-sided figure is 360 degrees. All right, that's not so cool just yet. All right, now let's come over and have you do this one on your own. Put me on pause again. Let's see if you can get those. Then once you have those 4 numbers on the outside, write a sum like this one, exterior sum, and put a 4, a little subscript before. Write up all your angles. and then find out what the sum of that one is. All right, put me on pause, see if you can do that one. Now that's what's neat. Depending on how many sides the shape has, the interior angles add up to something different each shape. 3-side is 180, 4-side is 360, a 5-sided figure is 540, but no matter what kind of shape it is, the sum of the exterior angles 360 degrees. This is a very big thought. The sum of the measures of an exterior angle of any polygon is 360 degrees, okay? So no matter how many angles you're adding up on the outside, they always equal 360. Have I said that enough? I hope so. All right, we're almost done. I got a couple of quick problems, quick ideas to have you run by. So over on the left, it says, what is the measure of one exterior angle of 11 gone? Okay, so now I don't have any degrees. All I know is the sum, the exterior angles add up to, the exterior angles of this 11 gone is going to equal 360 degrees. Okay, and I want to know what one angle is. Okay, so you know I have this shape, and I'm not going to draw all 11 sides, but because it's regular, all the interior angles are congruent. That means all the exterior angles are congruent. In other words, I have that 360 degrees that has to be divided up evenly to each one of these angles, and there's 11 of them. There's 11 exterior angles. So this is another little quick formula. The exterior angle of any regular polygon, not the sum, just one, is equal to 360 degrees, all of them added up, divided by the number of those angles. So if there's 11 here, I'm going to go 360 divided by 11, which turns out to be somewhere around 32.7 degrees. All right. Now use that same idea. I want you to just kind of look at those notes and create that same idea for an 18-sided figure. Okay? Find out what one exterior angle is for an 18-sided figure. Put me on pause. Come back and check your work. Now I got 20 degrees. Now make sure that you understand what we're talking about. Exterior angle is an extension of a side, right? And so it's this angle here. And so I'm saying that that angle there is 20. The next one after that is 20. Next one after that, 20. And I keep on doing this all the way around this 18-sided figure. So there's 20 of those, 18 angles, and each one of them is 20. The reason each one of them is the same is this word right here. It's regular. That only works for a regular polygon. If we go back to these shapes, you'll see that these triangles were not regular polygons. The exterior angles are all different numbers. The inside angles are all different numbers. So those are not regular polygons. All right, go ahead and write a summary real quick of what you've learned. Just go section by section. Quick, put it in sentences, and that means we're done. All right, so here's a bonus. Title it. Make sure you put it on another piece of paper. If you come in and it's on another piece on the same paper as your homework, I'm sorry, I'm not going to accept it. I'm not going to sit and watch you write it. So you should pull out a piece of paper and do this challenge real quick, okay? So it's kind of an exterior angle challenge. So I have this figure down below here, and it's some regular n-gon. All the exterior angles are the same. I don't know how many sides there are. I just know that this is a sampling from the sides. Now, it's not drawn to scale, so you don't need to pretend like that. It could be drawn like that, okay? All right, so anyway, to get credit, you're going to have to fully explain and show your work, okay? I'm not looking just for answers. So you might have to write sentences to get full credit. Question A, how many sides in this figure, and how would you calculate that and come up with an answer? And then question B, what is each interior angle worth in this regular polygon? Not the sum, but each interior angle. All right, very good. Here's your do it problems. Let's call this 7.1. All right, make sure you put your title on your page now as you're doing your homework. Don't make me watch you put your title on. Go ahead and write do it, 7.1 polygons, put your name and everything on it now before you begin. And then go ahead and make sure you write all the information on this page on your paper, show your work to get credit. Guesses, numbers just written from nowhere, no equations, I can't give you credit. Okay? All right, we're at that level now. So I'll zoom in and make sure that, well, actually, I don't think I need to. I think that's probably plenty size on your thing. So I'll see you next class. Take care.